The phenomenon of zombie ants, specifically those infected by the parasitic fungus Ophiocordyceps, presents one of nature's most intriguing and horrifying displays of mind control. This fungus, which primarily targets ants, has developed an elaborate method of spreading its spores by manipulating the behavior of its host. The term zombie ants is often used to describe these infected ants because the fungus effectively takes over their bodies and directs their actions in a way that serves the fungus's reproductive needs, often at the cost of the ant's life. The process by which zombie ants, under the influence of this fungus, contribute to building the structures that facilitate the growth and spread of the fungus is both fascinating and disturbing. When an ant becomes infected with the Ophiocordyceps fungus, the spores enter the ant's body and begin to spread through its tissues. The fungus releases chemicals that affect the ant's central nervous system, gradually taking control of its behavior. Initially, the ant might not display any symptoms, allowing it to continue interacting with its colony as usual. However, as the fungus spreads, it begins to exert more control over the ant's actions. The infected ant starts to exhibit strange behavior, such as wandering away from the colony, climbing vegetation, and displaying erratic movements. This behavior is meticulously orchestrated by the fungus to position the ant in an environment that will maximize the chances of fungal spore dispersal. One of the most striking aspects of the zombie ant phenomenon is how the fungus manipulates the ant to climb to a specific height on vegetation, often on the underside of a leaf or a twig. This height is not arbitrary. It is typically between 25 and 30 centimeters above the forest floor, which is the ideal microenvironment for the fungus to thrive. At this point, the fungus forces the ant to bite down on the leaf or twig in what is known as the death grip, locking its mandibles into place. This behavior ensures that the ant remains anchored in a location that is optimal for the fungus's development. After the ant secures itself in place, the fungus continues to grow inside its host. It gradually consumes the ant's internal organs and tissues, leaving only the exoskeleton intact. This process is essential because the exoskeleton acts as a protective casing for the fungus as it begins the next stage of its life cycle. The fungus then sprouts a long stalk, known as the fruiting body, from the back of the ant's head or thorax. This stalk grows outwards and eventually ruptures, releasing spores into the air. These spores can then be carried by the wind to new locations, where they may come into contact with other ants, thus continuing the cycle of infection. The positioning of the ant during its final moments plays a crucial role in the fungus's reproductive strategy. By forcing the ant to clamp onto vegetation at a specific height, the fungus ensures that its spores are released into an area where other ants are likely to travel. The environment at this height is also more conducive to spore development, as it is often more humid and shaded, which are ideal conditions for fungal growth. Additionally, the location of the ant's death grip often places it in the path of other ants, increasing the likelihood that the spores will infect new hosts. Interestingly, the fungus also appears to modify the ant's circadian rhythm, or internal clock, to ensure that it dies at a time of day when environmental conditions are most favorable for the fungus. Research has shown that zombie ants often perform the death grip around noon, which corresponds to the time of day when humidity levels are optimal for fungal growth. This level of control suggests that the fungus has evolved highly sophisticated mechanisms to manipulate its host, ensuring its own survival and propagation. The process by which zombie ants build their homes for the fungus is not a conscious act of construction, but rather a series of behaviors driven by the fungal infection. The ant's body becomes a vessel for the fungus, and its final actions serve to create an environment that supports the next generation of fungal spores. The death grip, the elevation on vegetation, and the timing of the ant's death all contribute to creating an ideal home for the fungus, which can then release its spores to infect other ants. In conclusion, the process by which zombie ants build their homes is a remarkable example of the complex interactions that can arise between different species. The Ophiocordyceps fungus exerts an astonishing level of control over its ant host, guiding it to perform actions that ultimately serve the fungus's reproductive needs. This manipulation results in the creation of an environment that supports the growth and spread of the fungus, ensuring its survival and the continuation of its life cycle. The study of zombie ants not only provides insights into the fascinating world of parasitism but also underscores the intricate and often disturbing ways in which organisms can influence each other's behavior and development. Thanks for watching. Subscribe for more.